Good morning, everyone. Today is our last class, or we could say that last lecture of this semester. In the next class, that's on Thursday, we will have a review class. Or if you have any question, you can ask me. If you have any doubt or issue, you can ask me. I will try my best to answer them. So today we are going to talk about firstly the transmission, reception, and processing. Then we will focus on the we'll focus on the application. We'll focus on the application and etc. etc. Something is wrong. Sorry. Still not working. Give me a moment. Okay. So the first thing we're going to talk about is how data is being received at the sensor, at the satellite, and then how they are going to transmit it back to Earth, and how they are getting processed. So when we have airborne aircrafts, what we do is we have the connected computers. The computer automatically starts to store the data. Okay, and then when the aircraft lands on the surface of Earth, we take that computer or we take that hard drive and plug into the system and start processing the data. So it's pretty common with the airborne data or with the land measurement. That means on the surface measurement or at the ground level data. But when it comes to the satellite, you cannot just bring the satellite back and again send it back to the space. So we have to improvise, and what we do is we have the communication satellites, as we have discussed earlier, and these communication satellites are connected with the satellite, the remote sensing satellite, as well as we have ground control station and ground station, which can the ground control station can have direct links to the satellite and can control the direction and the function of the satellite. On the other hand, the ground ground station, or simply the ground stations, they have direct link to the satellite to download the data or to transmit the data. So that's what we do. That's where it says the data can be directly transmitted to Earth if ground receiving station GRS is in line of the site of the satellite. Okay, so we have to remember that the Earth is round. So that means if the Earth is round, let me see. Okay, so that means I need some space. So let me draw it here. So if Earth is round and you have one GRS, one ground control station at this point, but your satellite is flying on the other side of Earth, so this one doesn't really have any direct connection. And we have to remember that these ground control stations, or the big dishes that we see in the films, they have to have clear visibility or direct visibility, or in other words, they have to have direct connection with the satellite or anything from which they are receiving the signals. So since if they do not have the direct connection, for example, if they are over the horizon, we can say it over the horizon. In that case, we can take aid of the communication satellites. These communication satellites can receive the signal and relay it to the ground receiving station or ground control station. Okay, that's what it says. If this is not the case, the data can be recorded on board of the satellite, transmitted to a GRS at a later time, or it can be through the TDRSS. Okay, so for these, we use the communication satellites. So now, okay, so we have received the data, we have recorded the data, stored the data in GRS. Now what? So what we do is, for example, this is example of Landsat, and Landsat has its receiving station all over the world. Okay, but then the Landsat data actually comes from two stations. I mean, the data that you download, one is from Alaska. Okay, so that's LP, sorry, that's LDAAC Alaska. Okay, and another one is from USGS. All right, so these are the stations, and another one is the server of USGS. So from this perspective, we can say that, all right, so this is the control station, which is actually processing the data, as well as we are also having these two stations which have the capability of processing the data. So what are the functions of these stations then? So we know that the entire world is now connected with the high-speed internet. So these ground receiving stations, what they do is, if they do not have the capacity or capability of processing the data, they simply receive the data, store it, and immediately they send it to the control stations. Okay, and then control stations runs the algorithm to process the data. Now, interestingly, one of you have contacted me this morning that he or she is not able to download Landsat 8 data. I mean, there is no option for downloading direct downloading Landsat 8 data. However, for the Landsat 5, 4, and 7, there are options to make the direct download. And why is that? Because we have to understand that Landsat 7 or Landsat 4.5 data, they are at now, they are almost a decades old data. The last data we have received maybe in 2013 or 2012. So we had 5 years, and we had already a well-established algorithm to process them, and we have finished processing all the data of these. So since the guys or the people who are working in these places, they have already finished processing this data, they are readily available online. Whereas if we think of the Landsat 8 data, we're still receiving the data, we continue to receive the data. Therefore, it's not really possible, or it is not feasible to make it readily available. So that's why you have to order the data. You have to put the data in the cart, and then you have to say that, all right, I would like to have this data, please process it for me. And they will process it, and they will send you an email within few hours. And all you have to do is click on that link and go to the download site and download it. It's that easy. But to complete your term paper, do remember that Landsat 8 uses different formulas for the pre-processing. So if you use the formula of Landsat 4, 5, or 7, it's not going to work with Landsat 8. because the configuration of Landsat 8 is more advanced. It's different than Landsat 4, 5, and 7. So if you would like to work with Landsat 8, they're most welcome. I really appreciate that, but you have to go through the handbook of Landsat 8 first to understand the formula, to understand how to process the data, and then do it. Otherwise, it will be just error and you will receive minimum marks. Okay, so however, if you are willing to take that pressure on you to read, to go through the handbook of Landsat and then follow that handbook to process the data, and if it's correct, of course you will get some bonus marks. Anyway, so this is how the ground receiving station and the ground control station works, and that's how they can provide the satellite, more specifically in this case Landsat 8 data, to the end users. Now we can see some of the stations stationed in the in North America. Okay, so it reads that in Canada, Canada Center for Remote Sensing operates 2 ground receiving stations. All right, so one is in Quebec, just outside of Ottawa. Another one is in Prince Albert. Excuse me. So this one is GSS and this one is PSS. Okay, so these are the 2 locations, and these 2 locations, this is the this circle is the area that could cover that they could cover. So if any satellite is on the horizon located here, then PASS could receive the data from that satellite, but GSS would not or could not receive the data from the satellite. At some point, if the satellite is located here, then none of the station will be able to receive the data from the satellite. In that case, we have to have one communication satellite, which is geostationary. The signal will be sent back to the communication satellite, and the communication satellite might send it to the nearest GSS at that point. Sorry, GRS. Now, EDC DAAC. So DAAC is Distributed Active Archive Center. Most of the NASA facilities where they archive different data and they distribute these archive data are named as DAAC. So there are EDC, there are LP, DUC, etc., etc. So the first part of the name refers to the station. Where is it located? Okay, so if we look into the Landsat data distribution system, then we can find that this is the international ground stations. So what are these international ground stations? So these international ground stations are where the ground stations are located, not in USA, but in the rest of the part of USA. So we have these ground stations, and these ground stations, they send the data to the DUC. Also, and we have Landsat 7 processing system, which is known as LPS. So you have already seen the different levels of data available for all the Landsat satellites, right? So it can process the data. It can run the algorithms, and it can process the data to the different levels of the data. And what do I mean by different levels of data? We have seen the level 1 data, level 2 data, level 3 data. Level 1 data is the raw data, which is not really processed. Not so much processing has been done. So you have the flexibility, or you have the opportunity to play with the data and make every possible thing with the data. I mean, you can run any algorithm for atmospheric corrections. You can run any algorithm for radiometric corrections and so on, or geometric corrections. Okay, but if you use level 3 data, which is already with the surface reflectance, if you can recall the surface reflectance as R, which gives us the data at the surface level of Earth. Okay, so that means this data has already been radiometrically corrected, calibrated, atmospherically corrected, and calibrated, as well as geometrically corrected. So it's a ready data. All you have to do is now you have to process it, and it's always wise to check the data whether it has any geometric distortion or not. Even this level 3 data. So this one is readily available. I mean, you can simply download it and then run NDVI or any other indices, or you can run classification on the data. But then you do not have the independence, or you do not have the liberty to choose what sorts of algorithm to be used for atmospheric corrections or atmospheric calibrations or radiometric corrections and calibrations. Okay, so they have their own set of algorithms and they are running it. You cannot change it. So this is what these LPS does. So in the dark, in the system, what's happening is it archives the ETM plus, which is Landsat 7 Enhanced Thematic Mapper plus, level of data, etc. Receive fulfill orders. Okay, it gives you the interfaces, the browser, and it provides you the metadata so that you can look into the metadata and to check whether it fulfills your needs or not. It also performs the billing, accounting, and all these things. So you are the user. What you do is now you order the product, you collect the mission information, you search the catalog, okay, you receive the data products, and you check the status, okay, whether it's downloaded or not, whether it's available or not, etc., etc. So this one, Landsat Product Generation System, LPGS, is what it do is when we receive a product, or they receive a order for the product, they send it the product, or the system sends the order for the product, and it replies to this request. It makes a data request and so on. So it's the communication goes on, and then data is provided. So here is a very quick quiz that asking, what do you think would be some of the best atmospheric conditions for remote sensing in the visible portion of the spectrum? So I'm not going to ask you to answer this quiz. If you were in the classroom, I would have, but now we have very little time, so I'm going to give you the answers. It should be around noon. Why noon? Because at the noon, the sun is just on the top. Okay, so we have shadows directly on the ground. The shadow is not projecting on the sideways, so the shadows will have minimum effect on the scene. So since we are talking about shadows, that means we also have to have sun. If we have the sunny day, the sun is well lit, the area is well lit, so we have good reflectance, and we would have good visibility. To have the visibility, the atmosphere has to be dry. If it's not dry, if it's very wet, or in fact, if it's if there are some haze, or if there are some fog, then we will not see everything clearly. It will limit our visibility. So that's why we do not want to have that. We want dry environment. So that's also another interesting point, that for Bangladesh, the data that are available for Landsat, they are usually available. I mean, the data which can be used to observe the surface of Earth, they are available from November till February or a little bit of March. Sometimes some of the data are also available in October, but that depends on the weather. Okay, like even at now it's cloudy. At present it's cloudy. A few days back it was raining, so the October was going on. At the end of the October it was still raining. Today is the second day of November, but still it's cloudy. So if Landsat 8 was taking the scenes or collecting the data, it would not have the clear visibility to see the surface, the ground surface. So we also do not want any clouds, okay? Because the clouds, we already know that clouds cannot be penetrated by the optical spectrum. So if there are clouds, we will not be able to see what's going on at the surface level. So that's why in Bangladesh, when it's not raining, most of the time the sky remains cloudy. I mean, not the cloudy with the dark clouds, but the cloudy with the white ones. Okay, just before the autumn, the sky is filled with the white clouds. So, or maybe it's in autumn. So that's why we do not have clear visibility from starting of April till the end of October. And also no pollution. If there are pollutions, the pollutions will create some sorts of haze, smoke, or soot can block our visibility as well. So this video is quite interesting, but we are not going to play it. Rather, let's move forward and talk about the next topic, interpretation and analysis of So before we go into the interpretation of and analysis of the data, first thing that we will do, we will look into some of the satellite images, and we will try to interpret this data. Okay, so this interpretation is called visual interpretation. We are not interpreting the data with the help of computer or with the help of some mathematical analysis or the process. Rather, we are simply looking at the data and try to understand or try to interpret what's going on. So on the image left, we can see that it's January 7, 2019, and image on the right, we can see it's February 10, 2019. And this date is important. Why? Because at first I have shown you this image, and without date, if I have shown you the second image, you would have said that, all right, so there was a river, a large river flowing northern side from the southwards, and in the second image there is no river, so it's dry. Okay, so a drought is going on. That would have been your interpretation, but since I have added the dates now, so this is in January, and this first one that I have shown you is in February. Now your interpretation will simply be the opposite. How? You would say that, all right, so there might be some rivers or not river, but we can, by looking into these points, we might say that there were some rivers, and these shapes, they also look like rivers. These as well. So we can see that there were some streams or small rivers. But then in February, there was a huge flood in this region. Okay, so this is the upper catchment and this is the lower catchment. So now you see, based on the available, based on the metadata, so this is metadata, of course, when the data were collected. So based on the metadata, your interpretation has changed. And also we have done interpretation, two kinds of interpretation. In first interpretation, we thought that there was a drought going on, but then when we found out that the metadata, or when we looked into the metadata, we found out that it's no drought, rather it's flat. So another example here is before image and then after image. So before, there is nothing going on. We can see here is one settlement, other settlements or towns or cities, roads. Okay, so these are the roads, clouds, shadows, agricultural land, and a little bit of settlements, few dots here and there, like salt and pepper effect. Then agricultural land, patch of agricultural lands. Now remember, these patch of agricultural lands are actually connected to the roads or the streams. Okay, so since they sometimes follow the straight path and sometimes not, sometimes they're so meandering, we might say that these are streams, or maybe not streams, but there is a possibility that these are streams because they are so meandering in this part. All right, so this is our before image, and after we see that there's something is going on. And what's going on? This is actually landslide, or more specifically, we can say that it's mudslide. Okay, so mudslide has been going on in this, not going on. We have seen mudslides into these regions. So how do we know these are the mudslides or landslides? Because they follow the patterns of, what should I say? The spaces in between the hills or the contours. Okay, and this is the valley. These are the, we can see this is the valley. It's clearly visible with the smoothness and the, and the, what should I say, the beginning of the hills. So everything is moving towards the valley, and then they start to create the branches. So we can say that, all right, so these are the landslides. These are sorts of the interpretation that we can make. So now this image on the left is from 2017, right is from 2018. So this is one national forest, and due to the cyclone, this national forest was heavily damaged. So we can see the lack of vegetation in this region in 2017, and in 2018 we find that it's became lush again. Okay, although we have some clouds, but we can see the vegetation. This part is very green, this part is a little bit gray green. There is a mix of gray and mix of green. Why? Because this is a growing vegetation, it's not dense yet. All right, so from these we can observe the recovery of, or recovery after the disaster in a natural way, of course, in this case. So that's the recovering from Hurricane Maria. So now let's delve into the more technical interpretation and analysis rather than the visual interpretation and analysis. So two things are involved. The first thing is the identification and the measurements of various targets. Okay, so how are they influencing our interpretation? The first thing is we have to identify what's going on. For example, in this case, we have identified, okay, so something has changed between these two images, and we looked into the patterns. What are the change of the features, and what are the patterns of these features, the change features? And we have we have did this visual measurement saying that, all right, so if this is a town, if this is the town, and if this is the changed feature, that means this changed feature is quite large. Or if we look into this data, we see these are the small patches of the clouds. So that means this region is quite large. So we can say that, okay, so the flooded area is quite large, and we can see the flow of the water, how intense they are, and we can also identify the sediments. These are the flow of the sediments. Okay, and how do we identify the flow of the sediments? Because of the different tones, textures, etc. Okay, and also in this part we can see the directions of the flow. All right, so in here it's not really visible, but from these images we see the patterns of the flow. Okay, so even from these patterns we can identify that this area is quite elevated than this part. Okay, why? Because since due to the elevation the water is flowing hard, and that's why it's creating these marks of the water flow. On the other hand, this part, the marks of the water flow is not clearly visible, like this one, or even this one. Okay, so we can conclude that, all right, this region might be quite flat, not elevated as this region. So these are sort of the identification and measurements that we have to think. Okay, so I have already discussed about the features, okay, and all the objects. So our targets could be point, lines, or area features. So in these examples, we have seen aerial change. In this example, we have seen linear change rather than the entire area. They performs more like a linear fashion. And this region, it's linear as well as something which is related to the aerial. That means area. Okay, so to interpret the target must be distinguishable. That means it has to be different than the surroundings. Okay, they should have some sorts of contrast. So what you do is much interpretation and identification target in remote sensing is done by manually or visually, and it's done by the human interpreter. Okay, sometimes data, what it does is in many cases this is done using imagery displayed and pictorial form, which we have seen in these examples. We have seen the pictures, and we have found out the pictures were presented to us, okay, and we found out what is going on. So if you print it out and display it, then it's going to be analog format, okay. And now if you have the options of changing the contrast or changing the histogram of this data, they are in digital format. Okay, for example, this one, of course we can change the intensity of the images, we can change the contrast of the images, improve the visibility, improve the ability of being able to distinguish one feature than another features. However, if these data were printed, it would not be possible. At the same time, if we bring this data into the ENVI software or any remote sensing software, we can change the histograms, and that way we can interpret it even more accurately, in better way. And that interpretation, or to perform the interpretation, the thing that we do is known as enhancing or enhanced data. Just now the thing I said, the histogram enhancing. Okay, so that's what we do is we enhance the data to make a better visual interpretation. Okay. Sometimes what we do is we also run some sorts of algorithm to do the things automatically. However, whenever we do the things automatically, still we need some people sitting in front of the computer and try to understand what's going on. Okay, so this one, The things are already discussed. Have a look, read. If you have any question, let me know in the next class. I'm going to move to the more interesting part, that is the interpretation. How are we going to extract the information? What are the things that we must look into or keep our focus into? So there are 7 visual elements, okay, that are involved in interpreting or understanding what's going on, or even identifying or distinguishing the features. So they are tone, shape, size, pattern, texture, shadow, and association. So the first thing is the tone, and tone relates to the brightness or the colors of the image. So due to the brightness, we can identify or we can distinguish 2 different settings of the same sorts of features on the ground. Okay, how? For example, agricultural land. So these both are agricultural lands, but then these agricultural lands have 2 different tones. That means 2 different brightness. Due to these changes in tone, but remember this, they are agricultural lands. We do agriculture in this land, but due to the tone, now we can say that, okay, so in this place, we do not have any vegetation, but in here we have vegetation. So the bright ones are the vegetations. Okay, we could conclude that. Or we could say it's the vice versa. It's just the opposite. Why? Because if there is no vegetation, that means this agricultural land is abundant, and that's why it's bare land. Okay, that's why it has a bright tone, and it's very similar to the road beside, because this road is made of either asphalt or bare land, which is giving us quite bright tone. Also, if we look into this, we can identify the housings. So there is one house establishment which is quite brighter than the surroundings. So this is also interesting. We can find out, we may say that, okay, so this is another built up area, or another bare land which is very bright, and it has these vegetations. So by vegetation, by now, what I mean is there are some trees or grove of trees. How do we know that? Because we see some salt and pepper effects of the shadows, very dark, as well as a little bit of bright. Okay, a little bit of brightness. I mean, brighter than the darkest tones, the shadows. Okay, so from this tonal differences, we might conclude that these are vegetations, because the similar pattern can be observed here, in this here, a little bit of here, and also a little bit here. And these rest are agricultural land. So tone is quite important for us to understand. The next one is the shapes. So the shape is very important in remote sensing as well, or any feature detection. Why? Because the natural shapes are very irregular. What do I mean by natural shapes are irregular? If you look into a river, the shape of the river, it's very irregular. Yes, it's meandering, but then it's not similarly meandering, or it does not, what should I say, meander in the same way throughout its path. Sometimes it's straight, sometimes it's too curved, sometimes it's in between. Okay, on the other hand, if we look into the man-made features, or which is not natural, then we find the shapes are very regular. For example, if this is a racetrack or stadium, you see the shape is very regular. If this is a racetrack, the shape is very regular. Okay, if this is a street, the shape is very regular. The housing, the shape is very regular. If it's a rectangular, could be square, or could be even round. So using these shapes, we can easily identify whether something man-made is there or not. So this shape is very important if you do, for example, archaeology. So if you find the shapes on the ground or the changes of the tones on the ground have some, shapes which can be man-made, you might go and investigate. You can go there and start digging to find out if there has been any human settlement in the earlier days and so on. And size is also important. However, the size depends on the scale of the image, but then there are absolute size and also there are relative size. So the absolute size is how big it is. It depends on the scale of the image. So for example, if this image is 1 is to let's say 20,000, so that means 1 inch, let's say this is inch. So 1 inch in this map or in this image, you can take a scale, a ruler, and make a measurement whether if it's 1 inch or not. If it's 1 inch, then in reality it's going to be 20,000 inch. So if we take a measurement here and we find that if this is 1 inch, then in reality it's going to be 20,000 inch. And now you can divide this 20,000 inch with some numbers to find out how meter long it is, or how what's the feet long it is. So that's absolute size. The relative is how big is it compared to the surroundings or other features, and this is what is more important for us in remote sensing. Okay. Why? By looking into this image, we can say that it's a business establishment. So these are the housings. They are small. So in a household, we could have 1 member to 7 members maybe. So these houses, excuse me, these houses, they do not have to be very big. So they can be dense in some in a neighborhood, in a residential area. On the other hand, if we look into this establishment, it's quite large. So it could be some business establishment, recreational center, and something else. Okay. And we also have surrounding some buildings which are also larger than the houses in these regions. Okay. So simply by looking into this, we can identify some of the features which might be used for different purpose. And then the pattern. So the pattern is the spatial arrangement of the things, and they are very important. So even in the patterns, human, what should I say? Those which are man-made, they tend to have similar patterns. They tend to have very regular patterns. On the other hand, which is natural, sometimes they could have varied patterns and so on. However, remember, the pattern means the orderly repetition of the similar tones and textures. We have already know what's tones. We are yet to know what's texture. Okay, so for example, here we can see by looking into the repetitions of the tones and repetitions of the texture that, all right, so there is a pattern. Things are quite similar. So, and we have some straight lines. So we can identify, or we can conclude that this is actually housing. So this is a very nice neighborhood with lots of housings, and there are some trees in between the housings. So this is the conclusion based on the pattern. So as well as along with the shape, okay, for example, you are trying to find out some archaeological site in a desert, and you will find that there are some changes of tones in some regions. So these are the bright tones on the ground that they have, and also these are the patterns they have. Okay, so because of the tones and because of the shapes, all right, now we are able to distinguish the pattern. So they have some regular patterns. They have the repetition of the same tone, shape, and also the texture. So now we can go there. So this tone, shape, and texture is actually forming the pattern. All right. This is interesting. Don't forget this. And due to this pattern, now we can go there, we can start digging, and we can find a very interesting archaeological site. So the texture is nothing but the arrangement and frequency of the tonal variation. So how the tonal changes are arranged and how frequent they are. So in this example, we have already said that these are trees. Why? Because of the differences of the tones. But we did not identify what do we call it. We did not give it a name. What? The tonal differences. We did not give the tonal differences a name. And now we are giving it a name, and that name is texture. Okay. So based on the arrangement and the frequency of the tonal differences, we can identify whether some of the surface is smooth or it's rugged or rough. Okay, for example, this could be a sand dune which is very smooth, so that's why the tonal difference is very little. On the other hand, these are trees or vegetation or bushes, and they have shadows since they are elevated from the ground. We observe the differences depends on the density of the these bushes or the trees. So based on the density, we receive different tonal differences or different frequency of tonal differences. So now, based on the texture, we can actually identify we can not only differentiate the rough texture and the smooth texture, but also we can identify the approximate density of some features. For example, we can say that it's very dense in this region, but it's not very dense in this region, or even here, or even in this region. It's not that much dense. But then if you look into this region, they are very dense. The bushes, I mean, on the trees. And when we're talking about trees, we talked about shadows. So shadow is very important. Shadow gives us the idea of the height as well as it creates the three-dimensional views, thus creating the the density, the impression of density. So shadows provide an idea of the profile and related, just like I said, relative height of the target or the targets which make make identification easier. If we look into this aerial image of the urban area, we find that these buildings are quite higher than the surrounding buildings. Okay, how? Because of the shadows and so on. And finally, the association, the relationship between the distinguishable objects. So by looking into this image, we know, I mean, we cannot identify sorts of anything. I mean, we can identify the road. Yes, this is maybe a path. Some of the trees, this is maybe park. This is maybe park. Trees, roads, again, these may be highway, okay, some building, etc. There is something, we do not know what that is. Some houses maybe, all right, maybe some ships. That's all we can figure. But then if we start thinking of the association, we might find that, all right, so this is actually a harbor. are the ships which are anchored into the jetty. So yeah, I mean, from the satellite image, it's not really possible to identify or distinguish whether this one is harbor or a jetty or not. Or if someone asks you, okay, where is the harbor in this satellite image or aerial image, you can say that, oh, it's here, it's located here. How? Because you associated the pattern of the ships here and the establishment here. Okay, so you connect these two information together and you say that, okay, so this is where the harbor is. It's also very interesting how, because sometimes you might feel difficulty in identifying the roads and the rivers. Okay, because roads, they can be also meandering like rivers sometimes. So how do we identify or differentiate the roads and the rivers? One of the thing is the width. So rivers width could change, whereas roads width could remain constant. However, on the other hand, another consideration is the housing. Along the river, you might not have single houses, but along the road, you could have single houses. So if you have different houses on the both side of road, you could conclude that, I mean, both side of this feature, you can conclude that this is actually a road instead of river. Because if it's river, you would have a human settlement instead of having the single housings. Okay, so this is also comes from the association. So now that's the interpretation part. What's the analysis? So the analysis has few things, and you have actually already done what's in the analysis in the labs, in the lab 2 and lab 3. So you have done pre-processing. I think you haven't done the enhancement. Okay. Excuse me. You haven't done enhancement. You haven't done transformation, but you have done the classification and the analysis. So these two has already been done. However, I will talk about these two as well as these two. So there are 4 categories of analysis. The pre-processing is to prepare the image for further analysis. Image enhancement, what it do is we try to play with histograms to make the tones, I mean, to make all these visible or visual elements more what should I say, more distinguishable. We try to make all of them more distinguishable, okay, so that we can perform better visual analysis. And the process is the image enhancement. We try to enhance the image. At the same time, sometimes we try to make the image more sharp, or we try to make the image smoother. Okay, so that's also part of image enhancement. Sometimes after your classification, as I have discussed earlier, you have 3 land cover classes: vegetation, water, and urban area. And in these classes, sometimes you will find that there are some individual pixels of maybe this is water bodies. Okay, so this is actually vegetation, and inside this vegetation we have these pixel of water bodies. Okay, some pixels of water bodies, some pixels of urban areas, but we do not want it. I mean, at the same time, this is water, so inside water you might have some pixels containing vegetations, which is কচুরিপানা থাকে না এরকম. So there is some water-based vegetation could be floating on top of the water bodies, and thus some pixels could be identified as vegetations, but we do not want it for the sake of analysis, because we would like to have a generalized view. So that's why we would like to eliminate these pixels. And for elimination, what we do is we make the image more smooth. We run some filters. Okay, we run some filters. So this filter could be 3 by 3. Okay, so it's 1, 2, 3, 1, 2, 3, 3 by 3 pixel. So these are known as filters, or the size of the filters is related to the kernel size. So this is a 3 by 3 kernel filter. Okay, we can run this filter to eliminate these individual pixels. So this effect is known as salt and pepper effect. Right? Just like when you throw salt and pepper on your dish, it will create some these little dots, black and white spots. We do not want that. We would like to have a very clean image. So that's also this sharpening and smoothen, or making the image smoother. That's also part of image enhancement. Transformation is a little bit different. We run some algorithm, or we run some tools to transform the image into something different. Okay. For example, one could be tassel cap transformation. Tasseled cap transformation, which is also known as TCP transformation. Okay, so if you run the TCP transformation, it results into 3 different bands. So one of them is greenness band. And this greenness band can be used to estimate the biomass, because it has a very positive correlation with biomass. Okay, so through this transformation, the result of this transformation can be used, or the products of these transformations, image transformation, could be used for different purposes. So there are lots and lots of ways to do transformations. You have to read the books, you have to do the testing with them to learn more about them. For now, as a beginner, the image classification analysis is more important. With this, you train some image, you create the classification, and based on this classification, now you can do the analysis. These analysis could be time series analysis, temporal analysis, spatio-temporal analysis, and etc. and etc. The list goes on. Anyway, so in the pre-processing, we have already done. So what we do, basically, we do the geometric corrections, then we do the radiometric. These actually I have discussed in the previous class. The entire class was without the slide, but it was only about pre-processing. So I will spend little time on pre-processing here. So they generally grouped as radiometric and geometric corrections. Okay, so in the geometric corrections, we do the georeferencing to fix the things. In the radiometric, we calibrate and we correct any radiometric errors. Okay, so the radiometric corrections include data for the sensor irregularities, okay, or any atmospheric noise, and so on and so on. So you understand that atmospheric calibration and corrections are also part of radiometric radiometric processing, okay, or radiometric corrections. So everything together are radiometric corrections. On the other hand, if you have to fix the distortions or misplacing of the image, that's geometric corrections. So in previous class, I say that there is another forms of pre-processing, that is topographic. So if your landform is rugged, then you have different lighting conditions on the different sides of the rugged terrains. To fix that lighting conditions, we use topographic corrections. Okay, and this topographic correction is only needed in the rugged terrain, not on the plain surface. So very quick examples. This is the uncorrected image, true color image, and 432 false color image. Okay. So now if the image is corrected, then we find that where there are some variations of the tones and it seems like these regions were not lit enough or they were covered by haze or something. Okay, so now the lighting condition has improved. They are now more visible here as well, more visible, and this region as well are more visible now as well as this one. Okay. So the geometric corrections, as I said, it fixes the locations, and how do we do it? It's by georeferencing. Okay, so the original image, it's supposed to be in this orientation, but it was like this. So what we do is we fix them. We know that, for example, we know that A3 is supposed to be B1. So we connect these lines and automatically it transforms into or it comes back to the original location. So that's the geometric corrections through georeferencing. So through these corrections or through the pre-processing, we also remove some of the noises that we have. And what sort of noises that we remove? We remove the noises that are actually originated due to the malfunction of the sensor. Okay, for example, this is a single strip which has the absence of signal. Okay, so now what we can do is we can run a filter to fix this image, or we can use the pre-processing to fix this image. There are so many ways. Okay, so in the pre-processing, that means to make the image analysis and classification ready, whatever we do is pre-processing. Okay, if it's a fixing of noise, it's also pre-processing. If you're using Landsat image, which is after 2003, with the SLC sensor malfunctioned, okay, so in that case, you will have these sorts of strip of lines which are without data. So you could run different algorithms, or you can simply average the data, the surrounding data. For example, you have a filter which is 3 by 3. So you have 3, 3, 3, 3, 3, 3, 3, 3. Okay, so this pixel is unknown. So now what you can do is you can take the surroundings and you can put the average value. So average value would be 3. Okay, because the surrounding pixels are 8. So I mean 3, 3, 3, 3, 3 would give you 24. 3 plus 3 plus 3 plus 3 plus everything. If you sum them up, it will give you 24. And if you divide it by the number of pixels, which is 8, it will receive 3. So that means this value will be 3. So you can use these sorts of filters and run it in this image to fill out these gaps. Okay, or you can use more advanced algorithm to fix this error. I mean, still now, different scientists, they are working on Landsat 7 data, and they are trying to find out different innovative ways to fill that gap, the gap that satellite sensor has, or the satellite images has, not the sensor, but the images has. So that leads us to also another topic, that's the image enhancement. So in the image enhancement, what we can do is we can run the histogram enhance stretch at first. So what is histogram stretch? For example, this is the histogram that you have. Those who works with photo editing and what should I say, photo editing, as well as different graphics. okay, graphical work, they would identify, or for them it's very easy to understand what histogram is. So simply histogram is you have different values, and on the y-axis you have the intensity of the values. For example, this is from 0 to 100. 0 to 100. On the other hand, this is, we know we have in Landsat 457, it's 8 bits, so from 0 to 255 different shades. So now we find that the shades actually started at some location, which is 84. So at the value of 84, the variation started. So before that point, everything was 0, and it actually ended at 153. Okay, but our endpoint is 255. So that means we are actually wasting a lot of space without any value. As a result, our image is a little bit darkened. Okay, so what if the idea of histogram stretch is, all right, so stretch this histogram on the leftward and bring it to the 0, and this point to the rightward and bring it to 255. So in a way, for example, if you have a balloon, you know, this birthday, the colored one, try to stretch it, and you will find the color of the balloon is getting brighter or lighter. Okay, so the similar idea is applied in this region. The histogram, now the entire space of the visibility is filled with different values, as thus the image is brightened. Okay, so the image is brightened and everything is clearly visible compared to the previous display. So that's the main image enhancement for the visual interpretation and analysis that we do. But then after classifications, sometimes, as I mentioned earlier, that we have different salt and pepper effect. We have different pixels at some places where we do not want them, these ones. Okay, so to omit them, to remove them, what we can do is we can run different filters. So these are the filters, just like this one. Okay, these sorts of filters that we run, and we can remove these pixels in between. Excuse me. So there are different passes, different filters. This is, you see, it's smooth. So the low pass filter is smoothing the image. On the other hand, high pass filter is sharpening the image. Okay, so you see now the salt and pepper effect is almost gone. The image looks quite smooth. If we look into this region, you will find this one is has more salt and pepper effect, whereas in this region it's rather quite smooth. And in the high pass filter, it sharpens the image. So this is quite smooth image. On the other hand, if we look on the right image, we find that this is very sharpened. So what is image transformation? So image transformation is we combined multiple spectral bands and transform this band into a very different something. We create new bands by combining different bands. Okay, and these new bands or new layers or the results are created by different arithmetic operations, or maybe some algorithms. And the results that we get, it tells us some new information or gives us new things for measurement, or new measurement scales. For example, we have NDVI. So PCA, Principal Component Analysis. So from here, I will draw your, okay, I did not explain NDVI here. I will talk about NDVI here. And I think you have already done NDVI in your image. So what NDVI does is, tell you what, I will discuss NDVI in the next class because it's very interesting and it will take some time. Let me know if I miss it. Okay, on Thursday, do remind me at the beginning of the class that I'm supposed to talk about NDVI. So image classification. So image classification can be two types. One is supervised and unsupervised. So unsupervised classification is very straightforward. You have to run the algorithm and you have to tell the algorithm that how many classes do you want. What do I mean? What do I mean by how many classes? I mean, how many land cover classes do you want? So you might say that I want 8 classes out of a single scene. So what it will do is it will look into the signals. It will look into this histogram of the signals into these 8 classes. Sorry, of the entire band or the bands, the image, and it will find out how these classes are changing. For example, let's say we have these sorts of histogram. So what it will do is it will say that, okay, so my user, let's say you want 5 classes, right? So it will say that, okay, so my user want me to do 5 classes or to make 5 classes from the satellite image. So if I look into these histograms or the curves, I find that they can be grouped into 5 categories. Okay, so this is category 1, 2, 3, 4, 5. So what it does is automatically chops down into these locations. It finds that location automatically and say that this one is one class, this is another class, this is another class, this one is another, this one is the last one. Okay, so it totally depends on the variations of the tones and the brightness. And why does it do that? Because if there is something, for example, this region is separate than this region, right? It's different than these surrounding regions. Why? Because the variation of the tone, variation of the color, or the variation of the variation of, where was I? The brightness is different than the surroundings. So that means if we have something particular, it would have some difference in the brightness. So now if you want to, it's very straightforward. We have very peak for every classes. What if we do not have that peak? For example, like this, there is only one single and very little peak, but we have to divide it into 8 classes. So software, you do not have to worry about it. It will just simply put, you will only have to put the number 8 as output classes, output number of classes, and software will automatically calculate the values and it will find is sections where it wanted to make the 8 classes. Okay, so that's how the unsupervised classification works, because you are not supervising the classification algorithm. The classification algorithm is working independently without anyone's supervision. Okay, so now this is very easy to do, but it creates some sorts of problems. What sorts of problems? Since it works automatically, you do not have control over it. And since you do not have control over it, sometimes, and also since it purely works based on the brightness and the tones and everything, that means it works with the data, the values that we have at the background. Sometimes some of the classes are misclassified. And what do I mean by some of the classes are misclassified? For example, you want to separate river bodies from the land. So you say that, okay, make 2 classes. Okay, I want 2 classes. So of course, the water body has very different signal than anything on the land. by anything on the land. I mean, including vegetation, bare land, urban area, everything. Why? Why does it have very different signal? Because if we look into the spectral signature, we know that vegetation has these sorts of signals. Bare land has these sorts of signals. Okay, urban areas also has these sorts of signals. Whereas water body has very different. I will draw it in the blue color. Water body, the signal of water body is very different. It's very close to zero. So that's why now we can say that, all right, so it would be very easy to different these two categories. Okay, one is water body and another one is non-water body. But then if you run this in unsupervised classification, you will start to have some problems. If your water body is surrounded by vegetations and if your water body is a river and have sediments in it, due to the sedimentation or the presence of the sediments, it will start to give a curve. Sorry, what is the color? It will start to give a curve which might looks like this. Okay, so if the curve starts to like this, so for the pixels which are below this line, they will be categorized as water bodies, but which are on top of the line, they will be categorized as non-water bodies. Okay, so that means although these are water bodies, they became classified as non-water bodies. If the water body is not with the river, okay, if you have river and you have wetland at the same image, you will find that some of the wetlands are actually getting classified as non-water body pixels because the image has picked out the river pixels as water bodies because they are covering the larger area, thus the more significance to it, and then it's start to ignore everything non-water bodies. Not water is land, so it starts to ignore the pixels of the wetland and starts to categorize them into with the land pixels. Supervised classification is a little bit complicated, but you have full control over it. I mean, by meaning the full control, it depends on your experience, depends on your expertise, depends on your, excuse me, give me 1 second or few seconds, I have a call. Sorry everyone, একটু সময় বেশি লাগলো. Anyway, so where were we? In the supervised classification, then it's a little bit complicated, but it's more interesting, and you have better control over the over your final result or product. So in supervised classification, it's bifold. That means there are 2 steps involved, or you have 2 different polygons you have to use it. Okay. And also for doing supervised classification, you have to know the area better. That means the area that you are going to perform the supervised classification, you have to have idea about that area. And that's why in your term paper, I said to do the supervised classification of your hometown, because you are supposed to know about your hometown, right? So in supervised classification, I will skip these and I will come here. So in supervised classification, few things to know: that we have training polygon, okay, and we have reference polygons. So the training polygons are the first polygon that we apply to our image. So just imagine that you have finished your the pre-processing of your image, which was in lab 2. Everything is done. Now what you are going to do is you would like to do the classification into your image. You do the subset of your image. You cut the image only to the region that you are interested. And now what you do is you create ROI. Okay, so polygon, or we can say ROI. So ROI is the term that was used in your tutorials. So you create the ROIs. And how do you create the ROIs? You say that, all right, this is water bodies. So you create some polygons or region of interest on the water bodies. And the region, what do you think, is agriculture. So this is a false color image. That's why agriculture has vegetation, and it's that's why it's in red. So you create a polygon on pixels of agriculture, what you think is agriculture. You draw some polygons. And finally, you would like to identify rock. So the pixels that you think are rock, you draw some polygons on the rock. Then what you do is you run the classification algorithm. And the algorithm that you had run is maximum likelihood. Maximum likelihood algorithm. Okay. So you run this algorithm and you get this final result. And in this result, it gives you that, all right, this is river, this is agriculture, and this is rock. Now, while doing so, and a student sent me a screenshot where the training polygons were very large. For example, this is your study area, and he or she was drawing training polygons this big. Okay. And inside these training polygons, for example, for this training polygon B, it's large, but this entire area is homogeneous. That means the entire area below that polygon is purely agricultural land. There is nothing else. Okay. For this region, it's purely rock. It's a rocky region. There is nothing else. For this region, it's purely water bodies. So since it's purely water bodies, you can draw a pixel. I mean, if there is no variation in the water, if there is no sedimentation present into the water, if it's a lake, very clean, same tone, monotonous tone, then you can have as big polygon as you want. But if there are some variations, then you should not. Okay, ওখানে যদি ভেরিয়েশন থাকে তাহলে এত বড় পলিগন আঁকা যাবে না। কেন যাবে না? Because ultimately in remote sensing, what it does is it always looks into the spectral signature. So if it's monotonous, that means for water bodies, it will have simply this curve. There could be a little variation of the curve, a little bit variation of the curve, but the trend and the pattern of the curve would be the same. But now, if you have in some pixels, if you have some sedimentations, for example, then in these sedimented areas, the curve might be like this, which is a big deviation from the actual curve of water bodies. And now, since some of the pixels have this curve, now your supervised classification algorithm is confused. So what is this? Is it because in some part you have this very low value at different bands, and in some part you have quite high value? Okay, so it's going to be very confused. So since the algorithm is confused, it will settle down at the middle, and it will start to find out the pixels which are with these sorts of curve, and saying that, okay, so make every pixel water bodies which have this curve, these sorts of curve. Okay, now not only your water body will have these sorts of curve, some of the water bodies, or sorry, some of the coastal areas might have, the sand areas might have these sorts of curve as well. As a result, these sandy areas will be classified as water bodies. Okay. At the same time, some of your sedimented water has this pixel. Now they are not included into the water bodies. Why? Because the algorithm decided that this is the range of making the water bodies at the middle, for example. Okay, so now this part is omitted, and these pixels, the pixels which has this spectral signature, are now classified into different class. For example, rocky areas or in agriculture. So that means some of your water body pixel will be misclassified into other classes. Now, what is the solution? The solution is, instead of drawing this big size of polygons, try to draw small sized polygons with a variation of the signals. For example, this is the river that you would like to classify. I mean, there are some surrounding areas, but this is the river, the water bodies pixel you are drawing, and it has some sedimentations in this region. So what you do is, you come in and you say that, okay, so this is a dark pixel, this is water body, this is water body, this is water body, this one water body, and very close to the shore, this is also water body. Okay, so in every polygon you are taking, for example, 10 to 15 pixels most. Okay, so now for the algorithm, it's very easy to understand their signals. It's saying that, okay, so if it has this curve, this is water body. If it has this curve, this is also water body. All right, so at the same time, for example, this is the shore, so this is the sandy region. You say this is sand, this is sand, and the algorithm realizes the curve that it has is actually for the sandy region. So now the algorithm which will decide that, okay, so any curve between these regions is sand. Okay, on the other hand, if I find any curve of this curve belongs to water, and this curve belongs to water bodies. Okay, so as a result, everything that you draw become water bodies, and these parts become classified as sandy region. Okay, so now যে স্টুডেন্ট আমাকে দিয়েছিল সে এত বড় পলিগনে গেছে, এই পলিগনের নিচে ভেজিটেশন আছে, বিল্ট আপ এরিয়া আছে, তোমার বেয়ারল্যান্ড আছে, ধরো এখানে ভেজিটেশন আছে, এখানে বেয়ারল্যান্ড, এখানে বিল্ট আপ, এখানে হয়তো ওয়াটার বডি, এখানে হয়তো আবার বিল্ট আপ, কিন্তু এখানে আবার ভেজিটেশন। এখন সে নাম দিয়েছে এটা হচ্ছে ভেজিটেশন। Okay, but since now it has the pixels are not pure. So pure means these pixels does not contain the same entity. Okay, ধরো কিছু পিক্সেল আছে, এই পিক্সেলটা তোমার এখানে হচ্ছে তোমার পানি, তারপরে এখানে হচ্ছে বিল্ট আপ এরিয়া, এখানে ওয়াটার, আর এখানে ভেজিটেশন এর নিচে পড়ে, বিকজ একটা পিক্সেল তো অনেক বড়, ল্যান্ডসেটের গুলো এক একটা কি বলবো 3 is 900 ফিট, 900 ফিট বাই 900 ফিট, মানে 9 তলা বিল্ডিং এর সমান। ওকে, সো 9 তলা বিল্ডিং এদিকে ফালাই দিলে যেরকম হবে, আবার 9 তলা বিল্ডিং এদিকে ফালাই দিলে যতটুকু হবে। সো ইটস অলমোস্ট আওয়ার একাডেমিক বিল্ডিং অফ, আই মিন দ্য হাইট অফ আওয়ার একাডেমিক বিল্ডিং, যদি আমাদের একাডেমিক বিল্ডিং মনে হয় 11 তলা, অলমোস্ট অতটুকু সমান। ওকে, তো ওই থেকে যদি ফালাই দাও, মাটিতে যদি শোয়াই দাও, তাহলে যে লেংথটা হবে সেটা হচ্ছে তার একটা সাইড, এবং ওইদিকে আরেকটা সাইড। তো এত বড় এরিয়ার ভিতরে আমার ভেজিটেশন থাকতে পারে, ওয়াটার বডিজ থাকতে পারে, বিল্ট আপ এরিয়া থাকতে পারে, অবশ্যই থাকতে পারে। তো এই ধরনের একটা পিক্সেলের ভিতরে যখন মাল্টিপল এন্টিটি থাকবে সেগুলোকে আমরা বলি মিক্সেলস। এখন ধরো তুমি সুন্দরবনে গিয়ে নিয়েছো, তো সুন্দরবনের ওখানে শুধু ভেজিটেশন আছে। সো এই 900 ফিট বাই 900 ফিট বা 30 মিটার বাই 30 মিটার স্কোয়ার যে একটা এরিয়া, এখানে দেখবা শুধু ভেজিটেশন পাচ্ছ। যদি শুধু ভেজিটেশন পাও, সেটাকে আমরা বলছি পিওর পিক্সেলস। ওকে, পিওর পিক্সেল অর্থাৎ এটা হোমোজেনাস, এর ভিতরে আর কোনো মিক্স নাই। কিন্তু এখানে যদি মিক্স অফ এলিমেন্টস থাকে, মিক্স অফ এলিমেন্টসকে সে যদি কভার করে, সেগুলোকে আমরা বলি মিক্সেলস। সো যখন আমরা পলিগন বানাই, তখন আমরা এই মিক্সেল গুলোকে অ্যাভয়েড করার চেষ্টা করি। ওকে, অথবা কিভাবে করতে পারি, আমরা যখন এখানে দেখি তখন দেখছি এই যে এখানে লাল। ওকে, সো এখানে বড় করে একটা নাইকে আমি জাস্ট এই লালের উপরে আমি একটা এইভাবে একটা পলিগন ড্র করে দিলাম। এই লালের উপরে আমি একটা পলিগন ড্র করে দিলাম, বিকজ দিস ইজ ভেজিটেশন। এখানে গাঢ় লাল, এটাও ভেজিটেশন, সো এখানে আমি একটু করে পলিগন এভাবে ড্র করে দিলাম। ওকে, সো এইভাবে আমাদেরকে পলিগন গুলো ড্র করতে হবে, দেন উই উইল গেট বেটার classified image as a result. Okay, so now I have got my classified image. Now I have to do the accuracy assessment. And how can I do the accuracy assessment? Okay, and what is accuracy assessment? Why do I need it? এই যে ক্লাসিফিকেশনটা হলো, this classification is automated way, the algorithm, the built-in algorithm, if it's maximum likelihood, the maximum likelihood has done it, but we do not know whether this result is accurate or not. Okay, so we have to check the accuracy of this image, of this classified image, অর্থাৎ রিয়েলিটির সাথে এটা কি কতটুকু ম্যাচ করছে সেটা আমাকে চেক করে দেখতে হবে। and how can I do that? So one of the way to do is to use the reference polygons. So reference polygon কি করে? reference polygon again আমরা এখন 100% শিওর যে এখানে পানি আছে। আমি 100% শিওর যে এখানে এগ্রিকালচারাল ল্যান্ড, এটা আমি 100% শিওর যে এটা হচ্ছে রকি ল্যান্ড। ওকে, তো যেখানে আমি 100% শিওর, ওই 100% শিওর এলাকায় গিয়ে আমি এভাবে আরো ফার্দার পলিগন অথবা পয়েন্ট আমি বানাই, বানিয়ে এই পয়েন্ট গুলোর দিয়ে আমরা তখন অ্যাকুরেসি অ্যাসেসমেন্ট করি, যেটা তোমরা অলরেডি করেছো। সো কিভাবে করি, তখন আমি এই পলিগন গুলো ওখানে ইনপুট দিই। ইনপুট দিলে হয় কি, now software automatically creates a temporary land cover class, and it has already created land cover class using the training polygon. Okay, and it creates a temporary temporary land cover class from the reference image, and it matches two different land cover classes and finds out how many deviation that we have from this temporarily created land cover map. Okay, কতটুকু ডিফারেন্স আছে তাদের মধ্যে, কতটুকু সরে যাচ্ছে ট্রেনিং পলিগন দিয়ে তৈরি করা ল্যান্ড কভার ম্যাপটা, তো সেটাই অর্থাৎ কতটুকু অ্যাকুরেটলি আমরা করতে পেরেছি সেটা সে চেক করে দেখে। সে ধরে নেয় যে ট্রেনিং রেফারেন্স পলিগনের উপরে বেস করে যে ল্যান্ড কভার ম্যাপটা তৈরি হয়েছে, দিস ইজ দ্য অ্যাকুরেট ওয়ান, দিস ইজ দ্য মোর অ্যাকুরেট ওয়ান। কেন? কারণ আমি অ্যাকচুয়ালি জানি যে কোথায় কোন পয়েন্ট গুলো আছে, আমি তাকে আইডেন্টিফাই করে দিচ্ছি। ওকে, অলসো ইট অলসো ফাইন্ডস আউট যে আমার যে ট্রেনিং পলিগন গুলো দিয়েছি, সরি রেফারেন্স পলিগন গুলো দিয়েছি, এই রেফারেন্স পলিগন গুলোর ভিতরে ট্রেনিং পলিগন থেকে আমরা যে রেজাল্টটা পেয়েছিলাম, ওই রেজাল্টের কোনো মিস ক্লাসিফাইড পিক্সেল আছে কিনা। যেমন ধরো রেফারেন্স পলিগনে আমি বলছি এটা ওয়াটার বডি। ওকে, আমি বলছি রেফারেন্স পলিগনে আমি বলছি এটা ওয়াটার বডি, কিন্তু যখন আমি এই ট্রেনিং পলিগনের রেজাল্টের সাথে এটা কম্পেয়ার করলাম, দেখা যাচ্ছে এটা ওয়াটার বডি না হয়ে এটা এগ্রিকালচারাল ল্যান্ড হিসেবে ক্লাসিফাই করে রেখেছে সে। আমি রেফারেন্স পলিগন ড্র করেছি ওয়াটার বডি, কিন্তু এই রেজাল্টের সাথে যখন ম্যাচ করছে তখন আমাকে বলছে যে এটা তো আসলে বি, which is agricultural land. So that means এখানে পিক্সেলটা মিসক্লাসিফাই হয়েছে। ওকে, এখন তাহলে প্রশ্ন হচ্ছে রেফারেন্স পলিগন গুলো আমি কিভাবে পাবো, কারণ ওই অ্যাকুরেট জিনিসটা আমি কিভাবে পাবো। তো রেফারেন্স পলিগন গুলো বের করার একটা উপায় হচ্ছে আমরা হায়ার স্পেশাল রেজুলেশনের ডেটা ইউজ করে থাকি। যেমন ধরো এটা যদি ল্যান্ডসেট হয়, তুমি সেন্টিনেলের ডেটা ইউজ করতে পারো। ইউ ক্যান ইউজ স্পট ইমেজ, বিকজ স্পট আরো হায়ার স্পেশাল রেজুলেশন আছে, আরো ডিটেল তুমি দেখতে পাও। তো দেখে তুমি সেখান থেকে তুমি বলতে পারো যে তুমি সবকিছু আরো ক্লিয়ারলি দেখতে পাচ্ছ। সো এখান থেকে তুমি আরো শিওর হয়ে বলতে পারছো যে এখানে আসলে ওয়াটার বডিজ আছে, এখানে ভেজিটেশন আছে, এটসেট্রা। Another way is you can use Google Map. Sorry, not Google Map, Google Earth. Okay, so you can use Google Earth. You can go there, and Google Earth gives you the Maxar satellite images, which are very high spatial resolution. So Maxar এর ডেটা যেহেতু দিচ্ছে, GeoEye এসব স্যাটেলাইটের ডেটা যেহেতু দিচ্ছে, তখন তুমি আরো ক্লিয়ারলি জিনিসগুলোকে দেখতে পাচ্ছ। সো এখানে তুমি এভাবে পলিগন ড্র করে নিয়ে এসে তারপরে তুমি এটাকে সেম কোঅর্ডিনেট হতে হবে, এটা কিন্তু মাথায় রাখতে হবে। The coordinate information has to be same. Okay, the coordinate system has to be same. So এখানে যদি WGS84 ইউজ করো, GCS WGS84, ওখানেও তুমি GCS WGS84 এ ডেটা কালেক্ট করে ওই পলিগন গুলোকে নিয়ে এসে তুমি ওগুলোকে রেফারেন্স পলিগন হিসেবে ইনপুট দিয়ে দিলে। Alright, so that's also another way. Now let's say that you do not have access to higher spatial resolution satellite images or even Google Earth. তাহলে কি করা যায়? তাহলে এই স্যাটেলাইটকে now you have to use different band combination. Okay, different band combination লিখে সার্চ দিবা, হাজার হাজার ওয়েবসাইট চলে আসবে। ওই ওয়েবসাইটে দেখবা যে কোন কম্বিনেশন ইউজ করে কোন জিনিসটাকে ডিটেক্ট করা যায় খুব সহজে। So now you start to use different band combinations to identify things. For example, তুমি যদি শোর লাইন ডিটেক্ট করতে চাও, তাহলে তার স্পেসিফিক ব্যান্ড কম্বিনেশন যেটা আমি তোমাদেরকে প্রিভিয়াস ক্লাসেও দেখিয়েছি, করলেই হচ্ছে তোমার শোর লাইনটা খুব সহজেই ডিটেক্ট হয়ে যায়। তো ওইটার সাথে ডিটেক্ট করে তুমি এখন ওয়াটার বডিজ পিক্সেল গুলোকে ড্র করতে পারছো। তারপরে তুমি বললে আমি ভেজিটেশনকে ডিটেক্ট করতে যাচ্ছি, তোমাকে দেখা যাচ্ছে যে 432 বলছে ইটস দ্য বেস্ট ভেজিটেশন বিকজ ভেজিটেশন উইল বি আইডেন্টিফাইড অ্যাজ রেড। সো তুমি এখন লাল রঙের যেগুলো সেগুলোকে আইডেন্টিফাই করে দিচ্ছ এখান থেকে। সো দিস আর ভেজিটেশনস। তুমি আরবান এরিয়াকে ডিটেক্ট করতে চাও, there are some band combination which can identify urban areas. So সেইভাবে তুমি ব্যান্ড কম্বিনেশন চেঞ্জ করে নিয়ে তারপরে তুমি আরবান এরিয়াগুলোকে এখানে আইডেন্টিফাই করে দিলা। Okay, if you are using the same image for training polygon and reference polygon, you can use band combinations for reference polygons. You can play with different band combinations to find out, to build your confidence. Okay, training polygon করার ক্ষেত্রেও তুমি কিন্তু band combination ইউজ করতে পারো। So once you are done, then you run this is already discussed, unsupervised. Okay, এখানে এক্সাম্পল দেওয়া আছে ডিজিটাল নাম্বারের যে ভ্যালু সেগুলোর উপরে বেস করে দেখো 11, 14, 12 এটা একটা রিজিয়ন তৈরি করে ফেলেছে, রিজিয়ন এ। মাঝখানে 96, 96, 98, 87 যেগুলো ইন বিটুইন সেগুলোকে বি, যেগুলো হায়ার নাম্বার সেগুলোকে সি। ওকে, সো এইভাবে আনসুপারভাইজড ক্লাসিফিকেশন হয়ে থাকে। And the result of supervised classification here and the result of unsupervised classification is very different. So যেটা বলছিলাম, so now you run your reference polygon, you do the accuracy assessment, and it will give you the statistics. So এই statistics এর ওখানে আমাদের বেশ কিছু accuracy value থাকে, সেগুলোর মানে কি, Google it, they will explain it in better way. So rule of thumb, আমরা যে accuracy-টা চাই, আমরা normally we want to have it above 75% and better if you have above 80%. Okay, but then if you have more than 95% or even 92%, there could be something error going on. ওকে, কারণ এতটুকু অ্যাকুরেসি তো হওয়াটা একটু সন্দেহজনক। So finally, the final thing that we have to discuss is that's the supervised and unsupervised classification. As simple as that. It's totally depends on now how you can master these techniques. It depends on the practice and practice. Okay, তুমি GIS remote sensing আমি শুধু পড়ে গেলাম হবে না। ওকে, অঙ্ক শুধু আমি বইয়ের অঙ্কগুলো করে গেলাম, খালি ওই অঙ্কগুলোই ঘুরে ঘুরে করলাম, অনুশীলনীর এক্সারসাইজের যে পার্ট সেগুলো আমি প্র্যাকটিস করলাম না, তুমি অঙ্ক শিখতে পারবে? কেউ অঙ্ক শিখতে পারবে না এইভাবে। ওকে, আবার এক্সারসাইজের অঙ্কও আমি সবকিছু করে ফেলেছি, ওকে, কিন্তু মুখস্থের মতো হয়ে গিয়েছে। ওইটাকে এখন রিয়েল লাইফে গিয়ে আমি সবজির দোকানদারের কাছ থেকে কিনতেছি, তখন আমি আর ওখানে যোগ বিয়োগ গুণ ভাগ করতে পারতেছি না, তাইলে কি লাভ হলো? এটাও তো হবে না। তো তার মানে আমাকে বইয়ে হাতে কলমে আগে শিখতে হবে যোগ বিয়োগ গুণ ভাগ কিভাবে করতে হয়, ওকে, কিছু এক্সারসাইজ করতে হবে, তারপর সবজির দোকানদারের ওখান থেকে যাতে সে আমাকে ঠকাইতে না পারে সেইভাবে অঙ্কগুলো অ্যাপ্লাই করে আমাকে রাইট অ্যামাউন্টের টাকা দিয়ে ফেরত নিয়ে আসতে হবে, রাইট? So that's how life works, and that's how remote sensing and GIS works. You have to know the theory first, যে কিভাবে যোগ বিয়োগ গুণ ভাগ হয়, ঠিক সেভাবে কিভাবে কোন জিনিসটাকে ব্যবহার করতে হয় সেগুলো শিখতে হবে। শেখার পরে কিছু এভাবে ল্যাব ওয়ার্ক করতে হবে, প্র্যাকটিস করতে হবে। তারপরে নিজে থেকেই তোমাকে you have to play with different satellite images and you have to explore what can be done. Okay, and আমি তোমাদেরকে বলেছি কিনা জানি না, open one Twitter account and start to follow different professors. Some very interesting things are going on, okay, যেগুলো আমাদের দেশে খবর পৌঁছায় না। So that's এটাই হচ্ছে আমার মেসেজ, যে তোমাকে থিওরি করলে হবে না, প্র্যাকটিস করে যেতে হবে। যত করবে, যত এক্সপেরিয়েন্স হবে, তত এক্সপার্টিস বাড়তে থাকবে। The final topic of today is the data integration and the analysis. So finally what we do is sometimes we integrate and analyze data. Sometimes we take data from different sensors and make fusion. Okay, make fusion. So কি ধরনের এরকম ফিউশন আমরা সেম স্যাটেলাইট ডেটা দিয়েও করতে পারি। এর আগে আমি অলরেডি বলেছি pan-sharpen data, whereas panchromatic band has 15 meters resolution and multispectral data has 30 meters resolution. So what we do is, to do the pan-sharpen, we make a fusion of multispectral and panchromatic band. We make a fusion, and the final product that we get is all the components of multispectral, and our resolution increases from 30 meters to 15 meters. Okay, similarly আমরা যে করতে এটা গেল কি একই স্যাটেলাইটের বিভিন্ন ব্যান্ডের সাথে। Now we can combine multiple satellites. For example, you have Landsat. You can combine Landsat with Sentinel. Okay, তাহলে লাভটা কি হবে? লাভ যেটা হবে সেটা হচ্ছে Sentinel-এর resolution, spatial resolution 10 meters. Sentinel-2, that is. Okay, 10 meters resolution. Landsat-এর resolution 30 meters থেকে 10 মিটারে উন্নীত হবে। আবার Landsat-এর এখানে কিছু ব্যান্ড আছে যেগুলো Sentinel-এর হয়তো নাই, তো সেগুলো আমরা ইনকর্পোরেট করতে পারি। Okay, so now this is intra-satellite, this is inter-satellite. এটা হচ্ছে একই স্যাটেলাইটের ভিতরে, এটা হচ্ছে দুইটা স্যাটেলাইটের ভিতরে। Now what if, but কথা হচ্ছে এগুলো সবকিছুই অপটিক্যাল। All these are optical data. How about to combine it with different types of sensor? So optical এর সাথে বাকিগুলোকে নরমালি করা যায় কিনা আমি so far জানি না, but you can combine radar with LiDAR. You can make fusion of radar and LiDAR. যখনই তুমি রাডার এবং লাইডারের ফিউশন করবা, and এটা অলরেডি হয়েছে, there is a paper on Africa. I think it's in West Africa, Gabon. Okay, Gabon নামে একটা ম্যানগ্রোভ আছে, the largest mangrove. Google it. So গ্যাবনের উপরে নাসা একটা কাজ করেছে, নাসার কয়েকজন সায়েন্টিস্ট, সেই জায়গায় তারা করেছে কি, তারা হচ্ছে রাডার এবং লাইডার দুটোটাকে ফিউশন করে তারপরে তারা সেখানে যে বায়োমাস আছে, এই বায়োমাসকে এস্টিমেট করেছে। ওকে, সো বায়োমাসকে এস্টিমেট করে বলছে আমাদের এখানে ম্যানগ্রোভে কতটুকু বায়োমাস চেঞ্জ হচ্ছে ওভার দ্য টাইম। So radar and LiDAR, they can be fused. So finally, when you are done with all these fusions, transformations, and classifications, now you have to do the statistical analysis. And this statistical analysis can be done in GIS. You bring the data in GIS and you perform one is spatial SPT analysis, and two, you do spatial statistics. Okay, so দুটো জিনিস দেখে and multiple other statistics and analysis techniques তুমি অ্যাপ্লাই করে তুমি এখন তোমার ফাইনাল রেজাল্টটাকে প্রেজেন্ট করতে পারো। So this is a very basic quiz. Have a look into it. It's এগুলো পরীক্ষার জন্য এই কুইজগুলো ইম্পর্টেন্ট নয়, but they are very interesting. They might interest you. Okay, anyone has any question?
স্যার আমার একটা কোয়েশ্চেন ছিল, সেটা হচ্ছে স্যার আপনি ল্যাব 3 এর সাথে একটা রিজিয়ন অফ ইন্টারেস্টের একটা ফাইল দিয়ে দিয়েছেন যেটা হচ্ছে .xml ফাইল। এখন স্যার মানে আমি এই ধরনের ফাইল কোথায় পেতে পারি? যেমন আপনি যেটা দিয়েছেন হচ্ছে গিয়ে ঢাকার রিজিয়ন অফ ইন্টারেস্ট, আমি যদি ভুল না হয়, আমি স্পেসিফিক কিছু এরিয়ার জন্য যদি খুঁজছি সেক্ষেত্রে কোথায় পেতে পারি?
আচ্ছা, তো ওই রিজিয়ন অফ ইন্টারেস্টটা আমি কেন দিয়েছি, এই ল্যাবটা তো বানানো, সো এই ক্ষেত্রে আমি নিজেই ওখানে ওই যে রিজিয়ন অফ ইন্টারেস্ট ড্র করেছি। এনভিতে তোমরা কিন্তু ড্র করতে পারো, ওইটার ইয়া কিন্তু দেওয়া আছে। সো ড্র করার পরে ওইটাকে আমি এক্সএমএল ফরম্যাটে সেভ করেছি, বুঝতে পেরেছো? ইনস্টেড অফ সেভিং ইন শেপ ফাইল, আমি এটাকে এক্সএমএল ফরম্যাটে সেভ করে তোমাদেরকে দিয়েছি। কারণ আমি যদি শেপ ফাইল দিই, একটা শেপ ফাইলের সাথে তোমার আরো 4-5টা ফাইল একসাথে লাগে, তাই না? কিন্তু এক্সএমএল হলে তো এতগুলো ফাইল আমার লাগছে না, এবং এনভি হচ্ছে এক্সএমএল ফাইলকে তোমার ওই যে কি বলবো লোকেশন বেস করে সে রিড করতে পারে। সো আমি এটাকে এক্সএমএল ফাইলে সেভ করে তোমাদেরকে দিয়েছি যাতে হচ্ছে তোমরা ওখান থেকে এটা ধরতে পারো, ইজিলি অ্যাক্সেস করতে পারো, হারাই না যায়।
তার মানে স্যার এটার জন্য মানে আমাকে হয় ড্র করতে হবে, না হলে মানে অন্য কারো ড্র করা জিনিসটা নিতে হবে, তাই তো?
কোনটার জন্য?
মানে এই ধরনের মানে যেমন আপনি তো স্যার পুরোপুরি ঢাকার রিজিয়ন অফ ইন্টারেস্ট আমাকে দিয়েছেন, সেক্ষেত্রে আমি যদি চিটাঙ্গেরটা করতে চাই সেক্ষেত্রে আমাকে হয় ড্র করতে হবে, না হয়
আচ্ছা, রিজিয়ন অফ ইন্টারেস্ট বলতে তো তুমি বাউন্ডারি বলছো, তাই না?
জি স্যার।
হ্যাঁ, তো বাউন্ডারির ক্ষেত্রে তোমাকে তো ড্র করতে হবে না। তোমাকে যে আমি তোমাদেরকে বারকে রেজিস্টার করতে বলেছিলাম, BARC, বাংলাদেশ এগ্রিকালচারাল রিসার্চ কাউন্সিল। তো বারকে যদি ওখানে রেজিস্টার করো, তাদের ওখানে তোমার জেলা ভিত্তিক ডেটা আছে, বিভাগীয় লেভেলে ডেটা আছে। সো তুমি এখন তুমি যদি চিটাগং ডিভিশনের উপরে কাজ করতে চাও, ডিভিশনের বাউন্ডারিটা ওখানে নিয়ে, ওখান থেকে নিয়ে তারপরে এটাকে তুমি ইয়াতে নিয়ে আসো, এনভিতে নিয়ে আসো শেপ ফাইলটা, তাইলেই তো হয়ে গেল, তোমাকে আর ড্র করতে হচ্ছে না। আর এই অ্যাডমিনিস্ট্রেটিভ বাউন্ডারি তো ড্র করা পসিবল নাই, এটা তো মানে হাতে হাতে তো ড্র করা পসিবল নয় বা ডিজিটাইজ করা এগুলো প্রি ডিফাইন্ড বাউন্ডারি।
জি স্যার, আমি এটাই জানতে চাচ্ছিলাম স্যার কোনো ওয়েবসাইট অথবা কোনো লাইব্রেরি আছে কিনা। থ্যাংক ইউ স্যার।
আচ্ছা, তো এটা ছাড়াও তুমি ইয়াতেও পাবা ওই যে জিওড্যাশ। যদিও
জিওড্যাশ
জিওড্যাশ এখন প্রচুর সমস্যা তৈরি করছে, বাট জিওড্যাশেও অ্যাভেলেবল আছে এগুলা।
ওকে স্যার।
ইনফ্যাক্ট বাংলাদেশের যে কোনো অ্যাডমিনিস্ট্রেটিভ বাউন্ডারি তোমরা যদি গুগল করো, অনেক অ্যাভেলেবল আছে, দেশের ওয়েবসাইট বিদেশের ওয়েবসাইট অনেক জায়গায় অ্যাভেলেবল আছে। যে কোনো ডেটা ডাউনলোডের ক্ষেত্রে আমার একটা সতর্কবাণী থাকবে, সেটা হচ্ছে ডেটাটা ডাউনলোড করার পরে আগে ডেটাটাকে চেক করে নাও যে ডেটার মধ্যে কোনো সমস্যা আছে কিনা। যেমন ধরো কোঅর্ডিনেট সিস্টেম দেওয়া আছে কিনা নাই, ওকে, ডেটাটা দেখতে কি ধরনের, তার মেটাডেটা কি বলছে, এটা কে বানিয়েছে, রিলায়েবল সোর্স থেকে আসছে নাকি ওই যে উল্টাপাল্টা কোনো একটা সোর্স থেকে আসছে, বুঝতে পেরেছো? তো এই ধরনের জিনিসগুলো একটু চেক করে নাও, তারপরে ডাটাটাকে ইউজ করো। চোখ বন্ধ করে একটা ডাটা ডাউনলোড করলাম, পেয়ে গিয়েছি, কাজ করে ফেলবো, এরকম বলা যাবে না। তো এই জন্য আমি তোমাদেরকে বার্কে রেজিস্টার করতে বলেছিলাম, কারণ বার্ক হচ্ছে একটা তোমার কি বলবো গভর্নমেন্ট অর্গানাইজেশন, তাই না, নাকি সেমি গভর্নমেন্ট। সো তারা যে ডাটাগুলো দিচ্ছেন, তারা হচ্ছে রিসার্চ কাউন্সিল, তারা গবেষণা করে। সো তারা যে ডাটাটা পাবলিশ করছে, ইটস এ রিলায়েবল সোর্স। সো ওখান থেকে তুমি যদি বিভাগীয় লেভেলে ডাটা নাও বা উপজেলা লেভেলেও ডাটা নাও, ওই ডাটাটা হচ্ছে অ্যাকুরেট থাকবে। এবং তারা বলে দিচ্ছে যে আমাদের ডাটাগুলো হচ্ছে GCS WGS 1984 এর ইয়া দেওয়া, কি বলে, কোঅর্ডিনেট সিস্টেমে বানানো। সো ইউ নো এভরিথিং দ্যাট ইউ নিড। ওকে, এটাই। এনি ফার্দার কোয়েশ্চেন? ওকে, কোয়েশ্চেন না থাকলে আমি অফ করে দিলাম। সরি ফর দ্য ডিলে, আজকে একটু বেশি সময় নিয়েছি। অ্যাট দ্য সেম টাইম একটা কল আসছিল, বাট দ্যাট কল ওয়াজ ভেরি ইম্পর্টেন্ট। আমাদের যে ল্যাব হয়েছে